Alrighty, so always exciting to hear new ideas from our knowledgeable speakers. And speaking of ideas and innovations, next up we're talking about IoT. Now, IoT is radically changing many facets of our personal and business lives, as well as the operations of many industries. Sensor data has a different shape and composition than corporate data, and you can easily end up with tens of terabytes of it pouring into your systems every day. Those who tackle sensor data first will definitely reap the market share. Here to talk a little bit more about that, let's welcome Mr. Richard Winter, who is the CEO and founder of Wintercorp. Richard? Got a microphone for you here or there?
I'll use the podium.
Use
Thanks.
the podium, all right.
Thank you.
Thank you.
Well, welcome to a session on IoT data. I've spent my entire career in data management, and one thing I've learned about data management is that from the perspective of most users of systems and the perspective of most executives in enterprises, data management is invisible. It doesn't exist. What exists are the screens, the mobile apps, the things we can do with computers. And for example, people talk, when they talk about the internet, in the early days of the internet, people talked about killer apps. What's a killer app? What's a killer app today? Well, I don't know, it's been around for a while, but I'd say Google Maps is a pretty good example of a killer app. Most of us use it or something like it to get around in our cars or on public transportation. And what we think about is the app. But of course, underneath that app is an incredible database. And the management of that database, if it has any size or complexity, is an extraordinary technical challenge. And with IoT, Internet of Things, most of us think about the spectacular things that we can do more easily now because there are sensors everywhere in the world, everywhere from in our phones, sensors in our phones that tell us how far we walked today, or sensors in our homes that automatically adjust our thermostats to save money. And the history of Internet of Things to this point has mostly been about the apps. And most of the data that comes out of those sensors is actually trapped in those apps and managed as a resource only for those apps. And what's happening now, and what kind of prompts my wanting to address this topic today, is a shift which is just beginning to occur, where companies take the sensor data that comes pouring in out of the Internet of Things, and they begin to treat it as a corporate asset and integrate it with other data. Not only data from other sensors, but data from across the enterprise. And that allows them to provide additional value or solve problems that were otherwise unsolvable. And it's so kind of the dawn of a new era with the Internet of Things. Other speakers today are going to talk about the home and more consumer-oriented examples of this, so I'm going to, just for variety, focus on some industrial and commercial examples. Oh, so I have a clicker here. All right. So just to start with an example that a lot of us might have some familiarity with as a result of the trip to the conference, is on an airplane today, a commercial airplane, there are a lot of sensors, and they're all generating data every moment that the plane is operating. And the scale of that data is remarkable. Just the most modern airplanes in flight today have 10,000 sensors on board. Just considering the fleet of Boeing 787s, that adds up to petabytes of raw data per year, a petabyte being 1,000 terabytes. So when we talk about IoT data used in a commercial or industrial setting, the scale is almost beyond anything else. It's certainly at the upper limits of scale with respect to the data that companies have managed in the past. And interestingly, because the cost of sensors is going down, they're being used in more and more places, and so this number is going to go up. In fact, the Boeing number for the 787 fleet is expected to double in the next year or two, and then triple. And then they'll be in the range of exabytes of data per year, exabyte being 1,000 petabytes or 1,000,000 of the more familiar terabytes. So while Boeing is at the high end of this scale, many enterprises, I think it's going to be hard to think of an enterprise within a few years that doesn't have sensors feeding it data. And the scale of that data is going to zoom up in the typical enterprise in the same way. And we have a healthcare conference going on next door. Healthcare has been, has used sensors for years. I mean, every time you see a picture of a hospital bed in a movie with a patient in intensive care, you see actually lots of monitors. Those are connected to sensors, and that data flows into nursing stations where people take action. And actually, that's emblematic of another shift. So sensors have kind of entered many industries as something that helps you operate in the moment. And that's how they came to be on airplanes initially. Help the pilot fly the plane. Help the pilot understand, in that recent crash of the new Boeing model had to do with the altitude sensor failing. And that had to do with managing the plane in flight. So managing the patient at the moment, clinical care. But another part of this shift is saving more and more of the sensor data to analyze after the fact, because it provides insight into things that we couldn't know otherwise. And, so here are some examples of what's being captured by sensors on an airplane. And so why do you need all that data besides to fly the plane? And the answer is there are engineers analyzing the data to balance parts costs, parts revisions, how well a part fits with another part. They're using the data to predict maintenance. When an airplane needs some kind of complex repair, it doesn't just pull up to any old airport and find that the right mechanics and the right parts are there. If the repair is anything but the most routine, it has to be scheduled. And if you run the airline, you want to schedule it not too early and certainly not too late. And so that takes predictive analytics, which is driven by the sensor data. So predicting when parts will fail is another major piece of this. And then the third piece is managing the supply chain. You know, if a certain part has been failing more than we think it should, can we trace it back to the supplier? Can we get that supplier to solve the quality problem? Do we need another supplier? Do we need to reconfigure the supply chain because of a tariff that's just been, put on? There are all kinds of things that that have to be decided based on this sensor data, and that if you couldn't have this data to make these decisions in a precise way, you wouldn't have a competitive airline today. And here's another example of the same thing, which I never would have thought of before I heard this, which is operating a modern mine. This is a photograph of the kind of mining that's done to produce copper, gold, and molybdenum. And it's done with these enormous vehicles. Some of them are earth moving and scooping and that sort of thing, and some of them are just the vehicles that carry the ore out of the mine. And those can carry as much as 400 tons of ore. Now, it turns out that if a vehicle carrying 400 tons of ore encounters a pothole of a certain size, the entire vehicle can become inoperable. It can sink down in the mud. It can, it can have a delay that's unacceptable in terms of this 24/7 operation. So there are almost as many sensors on one of these mining vehicles as there are on an airplane. And the people who operate one of these big mines get about 2 billion sensor readings a day that are used to make decisions concerning vehicles, road maintenance, how the processes operators use to drive the vehicles, and so on. So it's another one of these stories where the mine, if you took away the sensors, the mining operation would be set back to where it was in the 1990s, and it wouldn't be able to provide the resultant metal at a price that would be competitive today. Now, lest you think this is only going on in giant vehicles, it's in smart cities, sensors are affecting the operation of almost every element of the infrastructure of a city, ranging from roads and bridges to buildings to the energy grid to health and pollution to waste collection. An interesting example of this are these trash containers that you see in a lot of cities now. They're solar powered. They compact trash automatically as they fill up, but periodically they have to be emptied. So they have sensors in them. They tell some central facility when they're getting pretty full, and a truck comes around and empties them. And so because of the sensors, the truck goes to the container only when it's time. And as a result of that, with X number of crews and trucks, you can service a much larger number of containers. And as a result of that, you can have much more trash going into these trash bins instead of on the street. So it's a noticeable and measurable increase in the quality of life in this across the city because of the sensors in the trash cans. And that's kind of an example of how it's touching our lives and pervasively affecting our lives. IoT sensors everywhere you can imagine. So why is this why is this a different problem in data management. Data management, that thing that we don't think about to begin with. Well, there are lots of interesting things here. I've already mentioned the volume. The volumes are extraordinary. And the thing about data volume is that when you have enough of it, it makes all the other problems harder. And not linearly harder, but exponentially harder. But sensor data is kind of worse than that because it has a different shape and different properties than the corporate data for which our database platforms have evolved to this point. In addition, sensors have certain problems that I'll elaborate on in a minute. But for example, they don't always work right. They sometimes stop sending data. Sometimes there are network problems and the data is corrupted by the time it reaches the central repository. There are unique challenges in the area of data quality for sensors. Sensor data is difficult to analyze for a long list of reasons that are kind of specific to it. And finally, there are a lot of analytical uses of sensor data that are kind of low latency, meaning you have to act on what the sensors are telling you pretty quickly. I mean, even if you're not the one flying the airplane, the airplane's not the right example today, but if you're not the one driving one of these mining vehicles who has to make the second-to-second decisions about what to do with the vehicle, you may be the one operating the mine. You get data that there's a problem with the vehicle or that there's a problem with the road that vehicles are moving on. You perhaps have to act on that within seconds or minutes rather than tomorrow morning. And so there's this quality to sensor data in many applications, I would say a growing set of applications, that even if you're doing the analysis back at the central facility, this is low latency analysis. This analysis can't wait a long time. So the combination of these factors presents a distinctive challenge in managing the data. And I'm actually running a little short here. I talked a little longer in the first few slides than I planned to. So let me just compress a bit here. So what sensor data is every record has a timestamp. It probably, if the sensor is attached to something that moves, it has a location, and then it has one or more readings, which might be temperature, pressure, velocity, acceleration, whatever. And these readings can be a long array of readings. So for example, maybe the sensor captures a reading every second, but sends data every minute. And so what it sends is an array of 60 readings following the timestamp. So it's so the data it's wavy. It's not discrete. It's not discrete constant information like a bank balance. It's a more variable thing, even if so. For example, let's say a sensor is in a brake system to tell you whether the brakes are overheating. And what you want to know is whether the things are in the normal range or whether they're beginning to trend outside of that range. Well, being in the normal range may be a lot of different values, and it may be different, have a different meaning at different times. So the data is more complicated to interpret than some other data we're familiar with. Second, sensor data formats are not standard. Typically, the sensor the functioning of the sensor is determined by the engineer who designed the device. So if there is a system on a vehicle for controlling the temperature of, say, the engine, then the engineer who designs that figures out what's most useful for that particular purpose. And if there are 10,000 sensors, as there are on a big airplane, then there are thousands of different engineers who've been choosing formats. And so the formats are very much non-standard. And they're not likely to standardize within the next few years. And so sensor formats are highly variable. I'm going to skip over this. I'll post these charts on my website. But sometimes sensor data has to be correlated. For example, temperature and pressure may have to be correlated because it may be the combination of the two that creates an exceptional condition. They're on very different scales that can be kind of complicated. Now here's maybe the most interesting part of the whole story. As Michael Porter is the sort of famous expert on competition, Harvard Business School. He recently wrote an article on IoT data, and his principal conclusion was that you get the really high value payoff when you can integrate the IoT data with the other data in the enterprise. And so I'll give you an example of that. I'll post a link to that on my website. I'll come back to the example in a moment, but I just want to show you the architecture. So what people normally think about is the edge. We're going to get a presentation about the edge later this afternoon, but that's out in the world where the data is being created and sometimes it's processed before it goes to the central facility. There's, in the blue column toward the middle, you see the security apparatus. There's a critical problem with security for IoT. That's also going to be a subject of a session today. There's operational use of sensor data, which I talked about briefly, represented by that brown column. And the new focus is this yellow column on the right, where you have analytics, data lake, and a data warehouse. That's where the magic is going to happen and where the new trends are developing. Boeing has implemented this kind of scheme that I talked about, where they have the sensor data going into a data lake where it's stored in its raw form, and then parts of it go into a data warehouse where it gets integrated with corporate data. They do some really remarkable things with compression. There are some big opportunities for compressing sensor data because when everything's okay, sensor data is boring. So if you're measuring the temperature of your engine and it's always in the normal zone for 3 months, then that 3 months of data isn't very interesting. It only gets interesting when it begins to drift out of the normal zone. So you can compress the boring stuff and devote more of your resources to the interesting bits of the sensor data. An interesting thing is, so they were storing the sensor data and using it to support engineers for a long time before they did this thing of integrating the sensor data with the business data. And that's when they started getting collaboration that resulted in the kind of the big payoff for them in their business. And I'm going to skip over that so I can end on time. But I guess my bottom line in this presentation is that the IoT thing all by itself is exciting to many people, and I think it's just beginning. We're just beginning to have it change our lives with Fitbits and all kinds of other things. But there's an era coming where there's going to be a much bigger leap forward that comes from better managing that data, treating it as an asset, integrating it with other data, in the case of enterprises with corporate data, and that'll produce remarkable insights that were not available to us before. And if you're kind of piloting the data strategy for an enterprise, then you want to drive toward one of these architectures and strategies where you can do what Boeing did, and where you can have the engineers and the business people talking to each other and collaborating as a result of their data being integrated in a way that it never was before. So that's my message for today. There's 1 minute left, so maybe I can take a question. Any questions? Yes.
What blows my mind is that there's 2 billion sensor readings per day from a single mining truck.
Yeah.
And so how do companies not take a look at this and just totally lose track and say, oh, here's our results from 2 billion sensor readings a day, and make totally erroneous conclusions? And
yeah,
you see what I'm saying? Like,
yeah, I think you're right that it's a big challenge. And so every sensor is there for some kind of purpose, at least if it's been designed correctly. And so, they get that operational purpose, whatever it is, out of the sensor data at the moment it gets emitted. And it might be knowing that the mining truck is in the right gear to go up a slope of that percentage. So they always get that value out of it. But then the kind of longer term analytics, I think it's a good question, but it's kind of like the question about web logs. For 10 or 20 years now, companies have, with increasing sophistication, been analyzing logs of visitors using their websites and getting better and better insights out of it. And it used to be they only knew that things like, our interface needs to be improved in this area because users are struggling with it. But now they analyze the customer journey, and they come to understand things at a much deeper level. That the people who actually apply for a mortgage loan always first ask about interest rates. It might be an obvious observation, but maybe they didn't design the website to leverage that. And when that insight was gained, they were able to take a step forward. And I think this analytics of the deeper analytics of sensor readings, kind of following a similar growth path to web logs, which initially were just impenetrable and almost useless, and bit by bit became more illuminating. That's my take on it.
okay, thank you. I deal with weblogs all the time, so imagining applying that to mining trucks, my mind wasn't going to very good places with that.
Okay.
Thank you.
Thank you.